The Yamato-class battleships were battleships of the Imperial Japanese Navy constructed and operated during World War II. Displacing 72,000 long tons at full load, the vessels were the heaviest and most powerfully armed battleships ever constructed. The class carried the largest naval artillery ever fitted to a warship, 9 460mm naval guns, each capable of firing 1,360 kg shells over 42 km. 2 battleships of the class were completed, while a third was converted to an aircraft carrier during construction. Due to the threat of American submarines and aircraft carriers, both Yamato and Musashi spent the majority of their careers in naval bases at Brunei, Truk, and Kure, deploying on several occasions in response to American raids on Japanese bases before participating in the Battle of Leyte Gulf in October 1944, as part of Admiral Kurita's center force. Musashi was sunk during the course of the battle by American carrier airplanes. Shinano was sunk 10 days after her commissioning in November 1944 by the submarine USS Archerfish, while Yamato was sunk in April 1945 during Operation Tengo. Background: the design of the Yamato-class battleships was shaped by expansionist movements within the Japanese government, Japanese industrial power, and the need for a fleet powerful enough to intimidate likely adversaries. After the end of the First World War, many navies including those of the United States, the United Kingdom, and Imperial Japan continued and expanded construction programs that had begun during the conflict. The enormous costs associated with these programs pressured their government leaders to begin a disarmament conference. On July 8, 1921, the United States Secretary of State Charles Evans Hughes invited delegations from the other major maritime powers France, Italy, Japan, and the United Kingdom to come to Washington, D.C. and discuss a possible end to the naval arms race. The subsequent Washington Naval Conference resulted in the Washington Naval Treaty. Along with many other provisions, it limited all future battleships to a standard displacement of 35,000 long tons and a maximum gun caliber of 16 inches. It also agreed that the 5 countries would not construct more capital ships for 10 years and would not replace any ship that survived the treaty until it was at least 20 years old. In the 1930s, the Japanese government began a shift towards ultranationalist militancy. This movement called for the expansion of the Japanese Empire to include much of the Pacific Ocean and Southeast Asia. The maintenance of such an empire spanning 3,000 miles from China to Midway Island required a sizable fleet capable of sustained control of territory. Although all of Japan's battleships built prior to the Yamato class had been completed before 1921 as the Washington Treaty had prevented any more from being completed all had been either reconstructed or significantly modernized, or both, in the 1930s. This modernization included, among other things, additional speed and firepower, which the Japanese intended to use to conquer and defend their aspired to empire. When Japan withdrew from the League of Nations in 1934 over the Mukden incident, it also renounced all treaty obligations. Japan would no longer design battleships within the treaty limitations and was free to build warships larger than those of the other major maritime powers. Japan's intention to acquire resource-producing colonies in the Pacific and Southeast Asia would likely lead to confrontation with the United States, thus the U.S. became Japan's primary potential enemy. The U.S. possessed significantly greater industrial power than Japan, with 32.2% of worldwide industrial production compared to Japan's 3.5%. Furthermore, several leading members of the United States Congress had pledged to outbuild Japan 3-1 in a naval race. Consequently, as Japanese industrial output could not compete with American industrial power, Japanese ship designers developed plans for new battleships individually superior to their counterparts in the United States Navy. Each of these battleships would be capable of engaging multiple enemy capital ships simultaneously, eliminating the need to expend as much industrial effort as the U.S. on battleship construction. Design. Preliminary studies for a new class of battleships began after Japan's departure from the League of Nations and its renunciation of the Washington and London naval treaties. From 1934 to 1936, 24 initial designs were put forth. These early plans varied greatly in armament, propulsion, endurance, and armor. Main batteries fluctuated between 460 ohm and 406 ohm guns, while the secondary armaments were composed of differing numbers of 155 ohm, 127 ohm, and 25 ohm guns. Propulsion in most of the designs was a hybrid diesel turbine combination, though one relied solely on diesel and another planned for only turbines. Endurance in the designs had, at 18 kN, a low of 6,000 mi in design A140J2 to a high of 9,200 mi in designs A140A and A140B2. Armor varied between providing protection from the fire of 406 ohm guns to enough protection against 460 ohm guns. After these had been reviewed, 2 of the original 24 were finalized as possibilities, A140F3 and A140F4. Differing primarily in their range versus 7,200 mi at 16 kN, they were used in the formation of the final preliminary study, which was finished on July 20, 1936. Tweaks to that design resulted in the definitive design of March 1937, which was put forth by Rear Admiral Fukuda Keiji. An endurance of 7,200 Nm was finally decided upon, and the hybrid diesel turbine propulsion was abandoned in favor of just turbines. The diesels were removed from the design because of problems with the engines aboard the Daewoo-class submarine tenders. Their engines, which were similar to the ones that were going to be mounted in the new battleships, required a major repair and maintenance effort to keep them running due to a fundamental design defect. In addition, if the engines failed entirely, the 200 ohm armor that protected that area would severely hamper any attempt to replace them. The final design called for a standard displacement of 64,000 long tons and a full load displacement of 69,988 long tons, making the ships of the class the largest battleships yet designed, and the largest battleships ever constructed. The design called for a main armament of 9 460mm naval guns, mounted in three gun turrets each of which weighed more than a 1930s-era destroyer. The designs were quickly approved by Japanese Naval High Command, over the objections of naval aviators, who argued for the construction of aircraft carriers rather than battleships. In all, 5 Yamato-class battleships were planned. Ships. Although 5 Yamato-class vessels had been planned in 1937, only 3 Euro-2 battleships and a converted aircraft carrier Euro were ever completed. All 3 vessels were built in extreme secrecy, to prevent American intelligence officials from learning of their existence and specifications. Indeed, the United States Office of Naval Intelligence only became aware of Yamato and Musashi by name in late 1942. At this early time, their assumptions on the class's specifications were quite far off. While they were correct on their length, the class was given as having a beam of 110 feet, and a displacement of 40,000 Euro 57,000 tons. In addition, the main armament of Yamato-class was given as 9 16-inch guns as late as July 1945, 4 months after Yamato was sunk. Both Jane's fighting ships and the Western media also misreported the specifications of the ships. In September 1944, Jane's fighting ships listed the displacement of both the Yamato and the Musashi as 45,000 tons. Similarly, both the New York Times and the Associated Press reported that the 2 ships displaced 45,000 tons with a speed of 30 knots, and even after the sinking of the Yamato in April 1945, the Times of London continued to give 45,000 tons as the ship's displacement. Nevertheless, the existence of the ships Euro, and their supposed specifications Euro heavily influenced American naval engineers in the design of the Montana-class battleships, all 5 of which were to be built to counter the firepower of the Yamato-class. Yamato was ordered in March 1937, laid down November 4, 1937, launched August 8, 1940, and commissioned December 16, 1941. She underwent training exercises until May 27, 1942, when the vessel was deemed operable by Admiral Isoroku Yamamoto. Joining the 1st Battleship Division, Yamato served as the flagship of the Japanese combined fleet during the Battle of Midway in June 1942, yet did not engage enemy forces during the battle. The next 2 years were spent intermittently between Truk and Kure naval bases, with her sister ship Musashi replacing Yamato as flagship of the combined fleet. During this time period, Yamato, as part of the 1st Battleship Division, deployed on multiple occasions to counteract American carrier raids on Japanese island bases. On December 25, 1943, she suffered major torpedo damage at the hands of USS Skate, and was forced to return to Kure for repairs and structural upgrades. In 1944 following extensive anti-aircraft and secondary battery upgrades Yamato joined the 2nd Fleet in the Battle of the Philippine Sea, serving as an escort to a Japanese carrier division. In October 1944, as part of Vice Admiral Takeo Kurita's center force for the Battle of Leyte Gulf, she used her naval artillery against an enemy vessel for the only time, helping sink the American escort carrier Gambier Bay and the destroyer USS Johnston before she was forced away by torpedoes from USS Heermann, which put her out of combat. Lightly damaged at Kure in March 1945, the ship was then rearmed in preparation for operations. Yamato was sunk April 7, 1945 by American carrier aircraft during Operation Ten-Go, receiving 10 torpedo and 7 bomb hits before capsizing. 2,498 of the 2,700 crew members were lost, including Vice Admiral Seiichi Ito. The sinking of the Yamato was seen as a major American victory, and Hanson W. Baldwin, the military editor of the New York Times, wrote that the sinking of the new Japanese battleship Yamato is striking proof if anyone needed of the fatal weakness of Japan in the air and at sea. Musashi was ordered in March 1937, laid down March 29, 1938, launched November 1, 1940, and commissioned August 5, 1942. From September to December 1942, she was involved in surface and air combat training exercises at Hashirajima. On February 11, 1943, Musashi relieved her sister ship Yamato as flagship of the combined fleet. Until July 1944, Musashi shifted between the naval bases of Truk, Yokosuka, Brunei, and Kure. On March 29, 1944, she sustained moderate damage near the bow from one torpedo fired by the American submarine Tunny. After repairs and refitting throughout April 1944, Musashi joined the 1st Battleship Division in Okinawa. In June 1944, as part of the 2nd Fleet, the ship escorted Japanese aircraft carriers during the Battle of the Philippine Sea. In October 1944, she left Brunei as part of Admiral Takeo Kurita's center force during the Battle of Leyte Gulf. Musashi was sunk October 24 during the Battle of the Sibuyan Sea, taking 17 bomb and 19 torpedo hits, with the loss of 1,023 of her 2,399-man crew. Shinano, originally warship No. 110, was laid down as the 3rd member of the Yamato-class, albeit with a slightly modified design. Most of the original armor values were slightly reduced, including the belt, deck, and turrets. The savings in weight this entailed meant that improvements could be made in other areas, including added protection for fire control and lookout positions. In addition, the 12.7 cm secondary armament on the first 2 Yamatos was to have been replaced by the 10 cm/65 caliber Type 98 gun. Although smaller, this gun was superior to the 127 possessing a significantly greater muzzle velocity, maximum range, anti-aircraft ceiling and rate of fire. In June 1942, following the Japanese defeat at Midway, construction of Shinano was suspended, and the hull was gradually rebuilt as an aircraft carrier. She was designed as a 64,800-ton support vessel that would be capable of ferrying, repairing and replenishing the air fleets of other carriers. Although she was originally scheduled for commissioning in early 1945, the construction of the ship was accelerated after the Battle of the Philippine Sea. This resulted in Shinano being launched on October 5, 1944 and commissioned a little more than a month later on November 19. Shinano departed Yokosuka for Kure 9 days later. In the early morning on November 29, Shinano was hit by 4 torpedoes from the USS Archerfish. Although the damage seemed manageable, poor flooding control caused the vessel to list to starboard. Shortly before midday, she capsized and sank, taking 1,435 of her 2,400-man crew with her. To this day, Shinano is the largest naval vessel to have been sunk by a submarine. Warships No. 111 and 797, warship No. 111, never named, was planned as the fourth member of the Yamato-class and the second ship to incorporate the improvements of Shinano. The ship's keel was laid after Yamato-gata's launch in August 1940 and construction continued until December 1941, when the Japanese began to question their ambitious capital shipbuilding program. With the coming of war, the resources essential in constructing the ship would become much harder to obtain. As a result, the hull of the fourth vessel, only about 30% complete, was taken apart and scrapped in 1942. Materials from this were used in the conversions of ICE and Yamato-gata hybrid battleship aircraft carriers. The fifth vessel, warship No. 797, was planned as an improved Shinano but was never laid down. In addition to the modifications made to that ship, 797 would have removed the two 155 ohm wing turrets in favor of additional 100 ohm guns. Authors William Garsk and Robert Dulin estimate that this would have allowed for 24 of these weapons. Yamato was eventually modified in 1944 to something akin to this. Specifications, armament. Although the primary armament of the Yamato class was officially designated as the 40 cm/45 caliber Type 94, it actually took the form of 9 46 cm/45 caliber guns. The largest guns ever fitted to a warship mounted in 3 3-gun turrets, each of which weighed 2,774 metric tons. Each gun was 21.13 meters long and weighed 147.3 metric tons. High explosive armor-piercing shells were used which were capable of being fired 42.0 kilometers at a rate of 1 or 1/2 to 2 per minute. The main guns were also capable of firing 1,360 kg 3 anti-aircraft shells. A time fuse was used to set how far away the shells would explode away. Upon detonation, each of these shells would release 900 incendiary-filled tubes in a 20-degree cone facing towards incoming aircraft. A bursting charge was then used to explode the shell itself so that more steel splinters were created, and then the tubes would ignite. The tubes would burn for 5 seconds at about 3,000 degrees Celsius and would start a flame that was around 5 meters long. Even though they comprised 40% of the total main ammunition load by 1944, 3 were rarely used in combat against enemy aircraft due to the severe damage the firing of these shells inflicted on the barrels of the main guns. Indeed, one of the shells may have exploded early and disabled one of Musashi's guns during the Battle of the Sibuyan Sea. The shells were intended to put up a barrage of flame that any aircraft attempting to attack would have to navigate through. However, U.S. pilots considered these shells to be more of a pyrotechnics display than a competent anti-aircraft weapon. In the original design, the Yamato-class secondary armament comprised 12 6.1-inch guns mounted in 4 triple turrets, and 12 5-inch guns in 6 double turrets. In addition, the Yamato-class originally carried 24 1-inch anti-aircraft guns, primarily mounted amidships. In 1944, Yamato, the sole remaining member of the class, underwent significant anti-aircraft upgrades, with the configuration of secondary armament changed to 6 6.1-inch guns, 24 5-inch guns, and 162 1-inch anti-aircraft guns, in preparation for operations in Leyte Gulf. The armament on Shinano was quite different from that of her sister vessels due to her conversion. As the carrier was designed for a support role, significant anti-aircraft weaponry was installed on the vessel, 16 5-inch guns, 125 1-inch anti-aircraft guns, and 336 5-inch anti-aircraft rocket launchers in 12 28-barrel turrets. None of these guns were ever used against an enemy vessel or aircraft. Armor. designed to engage multiple enemy battleships simultaneously. The Yamatos were fitted with heavy armor plating described by naval historian Mark Still as providing an unparalleled degree of protection in surface combat. The main belt of armor along the side of the vessel was 410 mm thick, with additional bulkheads 355 mm thick beyond the main belt. Furthermore, the top hull shape was very advanced, the peculiar sideways curving effectively maximizing armor protection and structural rigidity while optimizing weight. The armor on the main turrets surpassed even that of the main belt, with plating 650 mm thick. Armor plates in both the main belt and main turrets was made of Vickers hardened, which was a face-hardened steel armor. Deck armor Euro 75 mm thicker Euro was composed of a nickel-chromium molybdenum alloy. Ballistics test at the proving ground at Kamigabuki demonstrated the deck alloy to be superior to the homogeneous Vickers plates by 10 Euro 15%. Additional plating was designed by manipulating the chromium and nickel composition of the alloy. Higher contents of nickel allowed the plate to be rolled and bent without developing fracture properties. The relatively new procedure of arc welding was used extensively throughout the ship, strengthening the durability of the armor plating. Through this technique, the lower side belt armor, included in the ships as a response to gunnery experiments upon Tassa and a new Japanese Type 91 shell which could travel great lengths underwater, was used to strengthen the hull structure of the entire vessel. In total, the vessels of the Yamato-class contained 1,147 watertight compartments, of which 1,065 were beneath the armor deck. However, the armor of the Yamato-class still suffered from several shortcomings, many of which would prove fatal in 1944 Euro 45. In particular, poor jointing between the upper belt and lower belt armor created a weak point just below the waterline, causing the class to be susceptible to airdrop torpedoes. Other structural weaknesses existed near the bow of the vessels, where the armor plating was generally thinner. The hull of the Shinano was subject to even greater structural weaknesses, having been equipped with minimal armor and no watertight compartments at the time of her sinking. Propulsion: the Yamato-class was fitted with 12 Kanpan boilers, which powered quadruple steam turbines. These, in turn, drove 4 6-meter propellers. This power plant enabled the Yamato-class to achieve a top speed of 27 knots. With an indicated horsepower of 147,948, the Yamato-class ability to function alongside fast carriers was limited. In addition, the fuel consumption rate of both battleships was very high. As a result, neither battleship was used in combat during the Solomon Islands campaign or the minor battles during the island-hopping period of 1943 and early 1944. The propulsion system of the Shinano was slightly improved, allowing the carrier to achieve a top speed of 28 knots. Super Yamato-class battleships. 2 battleships of an entirely new, and larger, design were planned as a part of the 1942 Fleet Replenishment Program. Designated as Designer 150 and initially named Warship No. 178 and Warship No. 179, plans for the ships began soon after the design of the Yamato-class was finished, probably in 1938 to Euro 39. Everything was essentially completed sometime in 1941, but with war on the horizon, work on the battleships was halted to fill a need for additional warships, such as aircraft carriers and cruisers. The Japanese loss in the Battle of Midway, where 4 carriers were sunk, made it certain that work on the ships would never begin. In the 3rd volume of their battleship series, Axis and Neutral Battleships in World War II, the authors William H. Garsk and Robert O. Doolin asserted that these ships would have been the most powerful battleships in history, because of their massive 510 main battery and extensive anti-aircraft weaponry. Similar to the fate of papers relating to the Yamato-class, most papers and all plans relating to the class were destroyed to prevent capture at the end of the war. It is known that the final design of the ships would have had an even greater firepower and size than the Yamato-class, a main battery of 6 510 guns in 3 twin turrets and secondary dual-purpose armament consisting of 24 100 dual-mounted guns. The displacement was to be bigger than the Yamato, a S, and a side armor belt of 460 was planned. Destruction of records. On the eve of the Allies' occupation of Japan, special service officers of the Imperial Japanese Navy destroyed virtually all records, drawings, and photographs of all relating to the Yamato-class battleships, leaving only fragmentary records of the design characteristics and other technical matters. The destruction of these documents was so efficient that until 1948 the only known images of the Yamato and Musashi were those taken by United States Navy aircraft involved in the attacks on the two battleships. Although some additional photographs and information, from documents that were not destroyed, have come to light over the years, the loss of the majority of written records for the class has made extensive research into the Yamato class somewhat difficult. Because of the lack of written records, information on the class largely came from interviews of Japanese officers following Japan's surrender. However, in October 1942, based upon a special request from Adolf Hitler, German Admiral Paul Wennecke, attached to the German naval attaché in Japan, was allowed to inspect a Yamato-class battleship while it was undergoing maintenance in a dockyard, at which time Admiral Wennecke cabled a detailed description of the warship to Berlin. On August 22, 1943, Erich Groner, a German naval historian, and author of the book Die Deutschen Kriege, 1815–1945, was shown the report while at the Far One Quarter Air Headquarters, and was directed to make an interpretation, and then prepare a design sketch drawing of the Japanese battleship. The material was preserved by Erich Groner's wife, Mrs. H. Groner, and submitted to publishers in the 1950s. Cultural significance. From the time of their construction until the present day, Yamato and Musashi have carried a notable presence in Japanese culture, Yamato in particular. Upon completion, the battleships represented the epitome of Imperial Japanese naval engineering. In addition, the two ships, due to their size, speed, and power, visibly embodied Japan's determination and readiness to defend its interests against the Western powers, especially the United States. Shigeru Fukudome, chief of the operations section of the Imperial Japanese Navy General Staff, described the two ships as symbols of naval power that provided to officers and men alike a profound sense of confidence in their navy. Yamato, and especially the story of her sinking, has appeared often in Japanese popular culture, such as the anime space battleship Yamato and the 2005 film Yamato. The appearances in popular culture usually portray the ship's last mission as a brave, selfless, but futile, symbolic effort by the participating Japanese sailors to defend their homeland. One of the reasons that the warship may have such significance in Japanese culture is that the word Yamato was often used as a poetic name for Japan. Thus, the end of battleship Yamato could serve as a metaphor for the end of the Japanese Empire. See also: H-class battleship proposals, Montana-class battleship, Yamato Museum, notes. References. Bibliography. External links: Kure Yamato Museum.